coming to us from the International Association of Astronomical Artists, he's the president of the IAAA. Please join me in welcoming very heartily our first speaker, Jon Ramer.
Okay, to get started, let me put my beer down over here. All right, first off, let me ask a couple quick questions here. How many people here have been to Mars? Raise your hands. Yeah. I'm not believing you, and the little green guy in the back, no one thinks you're real either, so nobody's been to Mars, all right? How about Callisto, moon of Jupiter? Been there? Nobody? All right, Titan, moon of Saturn, atmosphere, rivers, anybody been there? Not a very well-traveled crowd, are you?
Just the airport.
Just the airport. The duty-free there smells real bad. All right, now let me ask this question. How many people would like to go to Mars, Callisto, and Titan? Yeah? Yeah, I kind of thought that, but everyone would raise their hands. You're a wise bunch of people here. All right? Lucky for you, I have been to all those places. Not physically, but in my head, I've been to all those places. And the lucky part is that I took the camera with me, and I brought the film back to show you the pictures. So how could I possibly bring the film out of my head? Well, easy. I am an astronomical artist. Specifically, I'm a fellow and the president of the International Association of Astronomical Artists. Since that's a lot of syllables and we're drinking beer, I'm going to call it IAAA from here out. Okay. The IAAA is the only guild of artists in the world that is dedicated to painting space, stars, galaxies, moons, planets, the wonders that are up that way. Now, I'm here tonight to talk to you about what the IAAA does with art and science. If this works. There we go. Art and science. Now, I can see some of you are thinking, art and science, what's that got to do with each other? Well, they are absolutely intertwined disciplines. And if I do my job right tonight, you will understand how inexorably intertwined art and science are. One makes the other better, and vice versa. And if I continue to do my job right, when you leave here tonight, you'll understand just how deeply your lives have been affected by astronomical art, whether you know it or not. So first, let me answer a little thing about art and science. All right? Science is about facts and understanding stuff. If you do this is going to happen, and this is the reason why it happens. Whereas art is about eliciting an emotional response, something in your brain that makes you feel wonder and awe, or in some cases, disgust and revulsion, depending on whose art you're looking at. Contrary to what many people want to think, people are not machines. We are driven by our emotions, and we learn from the things that we see and the things that we do. It's important to understand that art is the visual bridge between the parts of your brain that thinks and the parts of your brain that emotes, the things that you feel. Now, as old as humanity is, that's how old art is. Even before we learned how to write, before we invented alphabets, we were painting. People painted images 30,000 years ago in Australia on walls and rock formations, and they depicted not just the grounds and animals around them, but the stars in the sky above. 3,000 years ago, the Egyptians had learned how to make different colors and paint things and invented alphabet, but they were still utterly fascinated with the nighttime sky. 300 years ago, during the middle of the Renaissance, people were obsessed with the visions of what is above you. This painting here is one of a series done by an Italian artist named Preti, done in order to convince the Vatican to fund an astronomical observatory. This, I'll figure it out eventually. I've had too much beer already. This is Jupiter. This is Jupiter painted in the sky with the moons, and this was painted 300 years ago. This is a series of paintings done with Jupiter, Saturn, Mars and Venus in the sky the size of Earth's moon. And it was done in order to convince the Christian Church, the Vatican, to fund an observatory to look at the sky and record the stars and planets as it was seen. It was successful. People thought it was absolutely fascinating and funded this observatory. Now, 150 years ago, am I dropping you down here?
Yeah.
Is it better? No.
Can you hear me better this way?
I'll try both. How's that? 150 years ago, people were so fascinated with what's in the sky above, it wasn't just looking at the points of light that moved around. They were thinking about these places as actual places that you could go and see, and visit, and walk on. Paul Dominic Lapito painted this image in 1877 of standing on the surface of Saturn and looking up at the rings above. It's probably the first time that somebody has ever imagined being off of Earth and looking and seeing the sky from a different viewpoint. Now, in 1937, this is a painting. This is the Hubble Space Telescope image of the same planet. Lucian Renaud. I feel like I'm not being heard at all. You guys hear me at all? Really? So this is better than... Yeah. I'll keep trying. So this was painted by an artist in 1937. This man here, Lucian Renaud, was an accomplished astronomer, and he painted everything that he saw through his telescope. He painted images of Jupiter and Mars. He created a book called Sur l'Autre in French, meaning on other worlds. And he painted views of the surface of Mars and the surface of the moon. He fired up human imagination, and many, many other people started thinking about what's it like to be off of this planet and what's it like to look at other scenes that are not from this world. Another one of those famous people is Chesley Bonestell. I'm sure many of the people here have seen this particular image before. I've seen this image before. This is Saturn as seen from Titan, painted in 1952. At the time when all we knew of Titan was that it was a little dot of light orbiting Saturn. We had no idea what was there, nothing whatsoever. So Chesley imagined that it was a cold planet with snow, a frozen atmosphere, low gravity, so the mountains were real tall, and Saturn was really in the sky. Magnificent view. Chesley Bonestell is considered the father of space art, but he's more than that. In the 1950s, he painted a series of illustrations for an article in Collier magazine called Man Will Conquer Space Soon. It was written by none other than Wernher von Braun. And these articles were the inspiration for many, many of the engineers who joined NASA. They saw these images of art. Is this better? Yeah. We have the technology. All right. Okay. NASA engineering at its finest right there. Okay. All right. So, this series of articles in Collier's magazine titled Man Will Conquer Space Soon, written by Wernher von Braun, the man who invented the Saturn V rocket and took America to the moon, was illustrated by Chesley Bonestell. These articles here and these images were what many, many engineers credited with the inspiration to join NASA in the first place. Going to space, conquering space, going to the moon wasn't just about a winged torpedo spitting sparks at the back or a heat ray on top of a tripod. It wasn't some fantastical thing. It was an actual, honest-to-God science with rockets and fuel tanks and pipes and engineering that proved people can think this up and build this and actually go and conquer space. So many engineers that joined NASA joined because of these articles. Why is that significant? Okay? NASA and the Apollo program have created so much of the things in your life today that you probably don't quite realize just how deeply it's affecting you. This laptop computer, the Microsoft circuits, microcircuits inside it, they were developed for the Apollo space program to get the Apollo capsule to the moon. They needed computing power. Gaming joysticks. How many people have a Wii or a Nintendo or an Xbox, whatever? Yeah, that joystick you're using, it was invented for the Apollo lunar landing module. There was no such thing as a joystick before that until they figured out they needed some way to control the LEM as it came down. That was joysticks. So thank your Xbox for the Apollo program. All right. Cordless tools. You can't have wires in space. They get wrapped around things and stuff like that. Mylar insulation. The very concept of software coding was from the Apollo program. The Apollo program was imagined by Wernher von Braun and Chesley Bonestell and illustrated, and people believe because they saw the images that they can actually do it and go and conquer space. So many of the things that you take for granted today are because someone was inspired by a space article. All right. What is the next step, though? We're taking our first steps out into the solar system today, sending out robotic explorers and seeing the things that we cannot see from Earth and learning things that we just hadn't imagined before. But still, an artist is the first person to actually go and see and do this stuff. In 1979, Voyager 1, an electric image. Somebody saw this little plume right here and said, oh my God, that is an active volcano on a moon orbiting Jupiter. How can this universe be any more fantastic? Well, you're going to have an artist stand you on the surface underneath that plume of 300 kilometers high and show you what it's like in the caldera of Tavashtar Ishtar and show you what it's like to stand there. NASA's Juno probe is returning these incredible images from just a few thousand miles above this cloud surface of Jupiter and showing these incredible patterns and whirls and swirls and stuff. But only an artist can actually fly you down into the clouds and show you what they look like from below. It's actually not very good because it's dark. It's really amazing when you look at that screen in front of it right there. Okay. So only an artist can show you what the red spot looks like looking upwards from the red spot. Cassini's, NASA's Cassini probe, a magnificent probe, and here I'm going to say a toast to the Cassini probe and everybody that worked on that program. A magnificent science that craft returned. Yay, thank you everyone for toasting that. The Cassini probe, as it zoomed past Saturn's rings, it showed some incredible imagery. But only an artist can stop, get out, and hover over the rings a couple of hundred miles up and show you the grandeur in a way that our spacecraft cannot. I love this particular image. And the neatest thing about this image is it actually goes out, way out over here, and way out over here. I had to crop it down to fit on this. The full size of this is just breathtaking. Okay, so one of the things that art does besides illustrating and showing us places and things that we just cannot see, go, and do yet, is it illustrates concepts and things that we know have happened, and we have the facts about it, but we don't know what it looked like. So let's take a little review of some facts here. A 120-foot diameter object comes flying in from outer space at 33,500 miles per hour, about 60-degree angle. It gets so hot that it explodes somewhere between 3 and 6 miles altitude. The strength is about 3 to 5 megatons of TNT detonation. Creates a shock wave about 5 on the Richter scale. Flattens 80 million trees over 830 miles. Anybody know where that occurred? Exactly. It occurred Tunguska in 1907. Notice the reflection of the shock wave. This is why the trees in the middle were still standing straight up and down, and everything else was radiation pointed away from it. The lenticular clouds, as the heat wave goes up into the cold atmosphere. But my favorite aspect of this is here's the shock wave. This is the smoke trail of the meteor as it comes flying into the atmosphere, and this is the shock wave propagating back up the trail. This was an award-winning image done by Don Davis, a fellow member of the IAAA. This is what art does for science. It illustrates concepts, times, and places that numbers alone do not do. You put a camera where humans cannot go, and you show what it looks like. Absolutely astounding, the things that you can learn in 1 second of a picture versus an hour of reading numbers on tape. All right, so science inspires art. It makes art better, right? The physics, the geology, cosmology, astronomy. To be an astronomical artist, you're not an expert in any of them. You're an expert in all of them, or at least really good at kind of all of them. You have to understand that light reflects off of a rock the same way, whether the rock is on the moon, the Earth, or Mars. Gravity works everywhere in the universe. You drop a rock, it's going to fall. It may fall fast, it may fall slow, but it still falls. Rocks filled up, valleys are carved out, you have geysers, you have volcanoes, you have these kind of things everywhere in the universe, not just here on Earth. But the fact that they occur here on Earth makes it very, very interesting. So I'm going to wrap up and tell you a little bit about the latest IAAA project, which is called Our Alien Earth. There are places on our planet that have the same geology as places around the Earth. The Grand Canyon, Valley Marineris on Mars. There are geysers in Yellowstone, and there are geysers on Triton. They work off of the same physical properties. What works on one planet does the same thing on another planet. So you can visit one place and imagine that you're in that other place. The IAAA visits these locations, and we paint these views of alien worlds. And so we go there, we see these things, we have these workshops, and we create tons and tons of art of places that you just wouldn't think that you could ever get to see in your own life. So now it's time for some vacation pictures. Where was the first place we went or wanted to go? Mars. Okay? So here, this is the Grand Canyon. This is Ios Chasma on Mars. And here, I'm standing on the rim right about there, and I'm looking across Ios Chasma, and I'm going, man, I gotta throw a rock. I gotta throw a rock. So I threw a rock. And it didn't go very far, because I was actually standing on the rim of the Grand Canyon, but when I threw it, but I could see Mars below me. I could picture myself on Mars, and I created an image of me standing on Mars throwing rocks, just because, you know, I can. All right. Second place we went, Jupiter, Callisto. There's a place on Callisto that has these incredible pillars, and they are probably caused by a meteor impact somewhere this way from this particular picture returned by Voyager probes. And this is the ejected debris that landed on ice, and then after millions of years, the ice sublimated and was eroded by micrometeors and left these incredible tall pillars. Well, in Cappadocia, Turkey, they have pillars that were formed in the exact same way. A harder material was positioned on top, and then the sandstone below, being softer, eroded away and created these incredible pillars. As I was walking amongst these pillars, I could have sworn Jupiter was in the sky above me. It just felt like I was on an alien world. So I painted an image with that alien world, standing on the surface of Callisto. All right? Next up, Titan and the rivers. Everyone understands that there are liquid, flowing rivers, oceans, and seas, and an atmosphere on Titan. It rains on Titan. There are gullies. There are river canyons, erosion patterns. There's an ocean, multiple oceans. It looks just like Earth. And if you go to the right places on Earth, you see the exact same features on Earth that you see in pictures on Titan. So let's paint a picture of riding an inner tube down a river on Titan. You gotta have a real good bathing suit because it's awful cold water, liquid methane cold water. But you know, get the right kind of suit and you get a good inner tube, and it's a fun ride. As the water, the drops of methane rain are plopping into the water around you. Imagine that you're there, and you can actually see that you're there. All right. So our Alien Earth is a book project the IAAA is working on. If you want to see more projects, more places like that, we've got Pluto, we've got Triton, geysers. There are a whole bunch of stuff. If you're interested, go to that place and you can look at it. There's all sorts of free uploads, waterfalls, hills, neat stuff. And it's all about the fact that places on Earth look just like places elsewhere in the solar system. And if you want to walk amongst the pillars of Callisto, you have no further to go than Cappadocia, Turkey. If you want to see what it's like to be hiking through Valles Marineris on Mars, go on a walk through the Grand Canyon. The view is the same. The technology to get us there is a little easier, but the view is absolutely amazing. So, with that about how astronomical art has affected that little phone in your pocket, it's created because somebody dreamed it up and painted a picture of it. The airplanes that we ride around in, all of the neat stuff in our world today. With that, I'm going to say, anybody got any questions? And thank you for looking at our art, because that is the most important thing